In this video, I'm going to introduce the Simplex method and specifically how to set up problems using a Simplex tableau. So Simplex is a method for solving standard maximization linear programming problems. So what this means is that you have a maximized objective function and all your constraints are less than or equal some positive number, not counting the non-negative conditions, which you must have. So when we actually go to solve these, you'll see that we use row operations, but it's not going to be this same procedure, this Gauss-Jordan elimination we used before. It has a very different structure, and we have to be careful not to confuse the two. And really, again, the main focus for us is to set these up. Computationally, these can be very difficult. Typically, you'll be using something like Excel Solver or some kind of software to solve them, although we will do some simple ones for practice and for understanding the procedure. So what I'll start off with is a problem that we set up last time. All we did was write the constraints in the objective function. So just to remind you, this was the problem where we had the two styles of hair dryers. And so we decided to call the number of petites we were going to make x1 and the number of deluxes we were going to make x2. And so we had this rule about labor. You had 1 hour labor to make the petite, 2 hours of labor to make the deluxe. So we only had 3950 hours of labor. And so that's how I get that first constraint. The second constraint comes from the materials cost, which is $4 and $3 respectively. And we only have a budget of $95.75. And then again, our objective function, we're maximizing profit. And so the profit is $5 and $6 respectively. And so that's where we got all this. So what I want to do is talk about, well, how do you go from this, instead of trying to solve this graphically, how could you approach this with the Simplex method? And this is one that you'll get to solve on your own, but we'll at least set up and we'll use it as an example. So the first step is to write this as a system of equations. But the thing is, it's not just any system of equations that you're going to write. Very, very specific order. Order is really important with the whole thing. So if I was to do step one with this one, what I would do is I would look at my constraints first. Now, this isn't going to be part of our tableau. It's just understood. These are the constraints I'm interested in. Every constraint gets a slack variable. So what you can think of is a slack variable makes up the slack between the left and the right-hand side. So if this is actually smaller than or equal to 3950, there must be some number I can add to it to get 3950. And so that will be our slack variable. So this will be a slack variable of S1 and S2. Each constraint gets its own slack variable. And so what I'll do is I'll write this out as an equality with that slack variable. So this is going to be x1 plus 2x2 plus s1 equals 3950. And this next one's going to be 4x1 plus 3x2 plus s2. Now it can't be s1 because these aren't the same, so it'd be a different slack variable to make up the slack here. And so if you add in that slack variable, the idea is it makes it equal to 95.75. And then what about my objective function? So here's my objective function right here. Well, what we do is we bring over everything to one side. So you're going to have minus 5x1 minus 6x2 plus z equals 0. So anytime you're asked to set up the system of equations, this is what you're doing using slack variables. And now this gets translated into a Simplex tableau. Very similar to the idea of a matrix, but again, the way it's set up is much more important. With a matrix, you had a lot more freedom. The constraints always go above. They always go first. That's why I wrote this in that order. And you always label your columns, at least at the beginning and the end, because you need to know your solution. So we're going to have a column for every variable here. So that means we're going to have a column for x1, we're going to have a column for x2, for s1, s2, and z. And then we're going to need a column for these right-hand sides constants. This order is important too. So in other words, the variables here are slack variables here, and then your objective function here, your variable from that. So now my first constraint that I wrote as an equation has coefficients 1, 2, 1. There's no S2, there's no Z, 3950. And then my next one is 4, 3, 0, 1, 0, because there's only an S2, 95.75. And then we have minus 5, minus 6. There's no S's here, but there's a Z and 0. All right, so what we do is we put a line here so we can know that these are the constants that were on the right-hand side, and we put a line here to differentiate between the constraints and the objective function. Your objective function is always on the bottom here. You're never going to pivot on that row, but you're going to do row operations to it. And so this is the Simplex tableau, and so that's the setup. Understanding the setup is half the battle, because if you set it up wrong, you're going to do everything else wrong. So let's look at one more and practice this. much larger. We got 3 variables now, 3 constraints. The number of variables does not have to match the number of constraints. It just happens to. And so again, my first step is to write all of these as an equation. And so I'm going to need slack variables. I'm going to need 3 slack variables because we have 3 constraints. And then I have my objective function here. So here's the system of equations. For the first constraint, I got 3x1 plus 3x2 plus 3x3 plus my s1 equals 66. For the next one, I got 6x1 minus 2x2 plus 4x3 plus s2 equals 48. And then finally, I got 3x1 for the third plus 6x2 plus 9x3 plus s3 equals 108. And then remember, you need to rewrite your objective function. So I got minus 10x1 minus 50x2 minus 10x3 plus z equals 0. So now I can write my tableau, and remember, you want to label your columns. The order is important. So each variable gets a column, so x1, x2, x3, s1, s2, and s3, and z. And now you just write it exactly how you see it. So 3, 3, 3, 1, 0, 0, 0, and 66. Then I'm looking at the second equation, 6 minus 2, 4. There's no s1, but there is an s2, and 48. And for my last constraint, I got 3, 6, 9, 0, 0, 1, 0, 108. And then finally, my objective function. So the objective function with these negatives, this is going to be how we determine what we pivot. And so that's why it's kind of separated here. Whenever you write out your tableau, you actually have a solution right now, a basic feasible solution, but it's just not optimal. So remember, optimal is when we actually have the biggest z you can get. So anytime you're looking at these, you're seeing a current solution to the system. And after each pivot, you'll see a current system. So that's something you can certainly read about in the textbook as you're going through this. And so in the next video, what we'll do is we'll actually go through and solve these. But again, the most important part is practicing setting them up first so that you're comfortable with that aspect.